Right, welcome once again. This is a continuation of our discussion on the topic vectors. This is part B of lesson 1. If you have not viewed part A of this lesson, please do well to view it. The link to part A is given in the description of this video. Also, don't forget to hit the subscription button and also the notification button so that you will always get alerted anytime new lessons are dropped on this channel. Thank you very much. So in our previous lesson, we were able to give the definition of a vector quantity, and then we saw examples of vector quantities and few examples of quantities that are not vectors. In this lesson, we are going to be talking about vector representation. How do we represent a vector? Vectors can be represented using alphabet with arrows above the letters. So you see, any representation we are going to be using for our vectors must capture two things: magnitude and direction. So when using alphabets, you have something like this: P, Q, you can have P, Q, R, A, B, C, but there's going to be an arrow on it. That arrow is indicating that that quantity you are talking about has direction and is a vector quantity. The alphabet may be capital letters, maybe small letters, just any convenient way to write your alphabet with an arrow on it can be used to represent a vector. Also, a vector can be represented with a straight line. You see, like we said, that vectors are quantities with magnitude and direction. So any representation we are giving to a vector must capture the idea of its magnitude and its direction. So when using a straight line to represent a vector, the length of the line will represent the magnitude. Then the direction of the vector will be given by the angle that line makes with a reference point. Okay? And then the sense of the vector will be given by an arrowhead on the line. You can see a new term, sense of the vector, is appearing here now. What is the sense of a vector? We are going to be seeing that very shortly. So you can see that magnitude, direction, and sense can be captured using straight line, a straight line. Okay, and most times or sometimes when you are using lines, you will need to draw to scale. You have to choose a scale. We call that scale drawing. Although scale drawing is not part of what we'll be talking about in this lesson, because most of the things we'll be doing will be centered around analytical method. So we can just use discretion to draw our lines and carry out our analysis. All right. Now, you can also represent vectors in matrix form. That is, if you want to specify your vector in terms of unit vectors, I, J, K, or you want to talk about row vectors and column vectors, that is also a way of representing vectors, but that is not going to be part of what we are going to be discussing. So we'll be looking at the use of alphabets and straight lines. Okay, now, if we want to use a straight line, we need to have a reference, okay? And then we draw a straight line whose length will represent the magnitude of the vector. And then the direction, like we said, will be indicated by an angle that this line makes with our reference point. Mind you, our reference could be another vector, okay? So you can have two vectors acting, and then there's an angle between them. All right, and then the third thing we said was the sense of the vector. The sense of the vector. This sense is an arrowhead indicated on the line, and it could appear anywhere. It could be at the top. It can be anywhere along the line. So if we have vector P, we can see this capturing now, or this capture now. The straight line with an angle there, and then the sense. You can see this is a way to represent a vector. Now, talking about the sense, a combination of the sense and the angle is what gives you a complete idea of the direction of that vector. Now, you may be wondering what's the importance of the sense. Let's look at this. If we have a straight line representing a vector, and then we have the sense of the vector, let's call this P, and then we have another line again, and then we have the sense of the vector, Q. Now, what do you observe? You can see that the two senses are not pointing in are not having the same orientation. So you can now see that if we want to be more detailed and technical, even if their angles are the same, we won't say that these two vectors are having the same direction. So your sense and your angle gives you a complete idea of what the direction of your vector is. So very importantly, when using straight lines to represent a vector, you must indicate your sense. You must also indicate the angle that that line is making, or that vector is making, with a reference point. So the use of lines and then the use of alphabets with arrows above them are the two notations that we are going to be using throughout our lesson. So this brings us to the end of part B of lesson 1. Do well to hit the subscription and notification button so that you can always get alerted when new lessons are updated. See you in the next lesson, part C. In part C, we'll be talking about something very interesting, which is the resultant vector. So catch you in part C. Thank you very much.